Good.
Hey John, this is Ron Cottle. I appreciate you looking at this video for us, and anything you can give us heads up on little problems or whatever you see, would certainly appreciate it. Me and a guy named Michael, who's holding the camera right now, are going to walk you through this whole bottling procedure, and we're going to put this on YouTube and send it to you. So hopefully this will help us, and you can show us what we're doing wrong if we got any issues here. Thank you. So, John, this is where we'd start on this end. This is where we just using purified water. This is our mixing tank that we mix. The ingredients that we're using is a muscadine grape, that's a puree, a strawberry puree, and a blueberry puree. And we're either making a muscadine strawberry drink or a muscadine blueberry, and they're smoothies. So it's kind of thick texture. So from the mixing tank, we go into our holding tank.
Okay.
All right, and from our holding tank, then we're pumped out through the pump here. You see the pump?
Okay.
From that pump, the juice flows through the bottom. We go through a screen system. Then there's a magnet. From the magnet, it comes into the top of the tube. And this is called a what now, Michael? A tube and shell and tube?
Shell and tube heat exchanger.
And what are the name of the heat exchangers? Do you remember?
The brand, I don't remember.
Okay, well, it's
Interquip.
Interquip. That's the name of it, okay?
There's 8 tubes inside.
8 tubes. Okay, so John, what we're doing is the juice is coming in the top of this. We're introducing heat from steam. Our computer system here is set at, the steam is 216 degrees, and then the juice we're trying to heat it up to 185. So it enters the top of the tube, and then it comes back out the bottom, which I know you're familiar with. Then we got this, we're actually checking the temperature here. This checks the gallons per minute. This loop here is to ensure us of our 12 seconds.
And that's 24 feet in length of 1-inch stainless tubing.
Yep. And then we're going to the top of this other shell tube, and this is where the cold water is introduced. This is the valve that's introducing the cold water. We have 36 ton of a chiller outside that's putting about 25 degrees temperature on here, which will let the smoothie come back out. It comes back out of here, and here we're checking the temperature, and we're coming out less than 40 degrees.
Yeah.
So we're going from 185 here, all the way through our loop, going through the chiller, and coming out at less than 40, around 38, 37 degrees. From here, we have a valve that's controlled by our computer system, and controlled by the hopper, which is on the fill tank. And what happens if for some reason either temperature is not correct, whether the heat is not correct or the chill temperature is not correct, this valve will automatically kick in and send the fluid back to the holding tank. So if either temperature, the chill temperature we got set, or either the heat temperature is not correct, it sends it back to the holding tank. If the temperatures are correct, then the valve opens and allows fluid to then go into the top line, which then drops into our bottling room. As you can see, this is our bottling line here. It's a machine from Apex up in Illinois, right?
Yep.
They actually built the bottling line for us. You'll see where we put the bottles on here. Then the bottles enter into what we built a clean room. The clean room is over the section of the bottles where the bottles are exposed. The clean room has HEPA filters on top of it to make sure the air is clean that's going in it, and it's got a positive airflow. So when you shut the door, all you can do is feel the air coming out of 2 loops where the machine goes through. Also, the room that we're standing in right now is temperature controlled. We're running this temperature in this room at 40 degrees. The room inside the clean room is going to be 40 degrees also, just so you know. Okay, so we enter the bottles here.
Yep.
Onto the table. They then come inside. The bottles get inverted upside down, and from here they get sprayed with
Chlorine dioxide.
At what rate, Michael? Do you remember?
5 parts per million.
5 parts per million chlorine dioxide. From here, the bottle travels down the line to our fill heads. We're running 6 fill heads, and this is a gravity-fed feeder.
Okay.
All right. From here, the bottles run to the cattle. The way we're sterilizing the caps is with a UV light, which you can see here. And from here, the bottles then go outside the clean room. So the whole time the bottles are exposed or inside the clean room, that there's not, anytime there's not a lid on the juice, it's only in the clean room. This is what we're bottling in. It's a 12.5 PET plastic bottle.
No, HDPE.
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 PE, okay, plastic bottle.
We are going to switch though to a PET bottle as soon as we've gotten through this batch. So hopefully within a few months we'll be going to a PET bottle, which is a little bit more sturdy.
Okay. So now we'll step back outside the clean room and you'll see where the bottle comes out of the clean room. Okay, here's where the bottles would exit the clean room. From there, we'd put a born-on date or expiration date. From there, the bottle travels here. From here, we got sleeves, and we will hand put the sleeves on. This is what the juice is called, Juvenate, J-U-V-N-8. You can also Google that. There's a website for it already. Then from there, the bottles will travel through the steamer and then, of course, come out on the other side with the sleeves tightened up on the bottle. And from there, they'll be packaged into a 12-pack and then sent outside to be put into the cooler. Michael, tell me, is there anything I'm missing telling him that might be of importance to... Our main problem here, John, is, and elaborate with me, Michael, is that we are having a yeast problem. As we were talking to you about this machine that crunches up the 50-gallon drums, we're now currently bringing the product in as a puree in 50-gallon drums and having to wait anywhere from 8 to 12 days for it to thaw enough before we can actually have it thawed enough to run. So we know our yeast is actually growing some in there, but for some reason we're not getting a strong enough kill on our pasteurization system that when we bottle, we're still coming up with high counts of yeast. And I was talking to a friend of mine today that said that we needed to add what kind of acid?
Ascorbic acid.
Ascorbic acid to keep from any yeast growing in the bottle. So if you could elaborate on that too, or what your thoughts are on that, that'd be appreciative, because we can actually set these bottles in the refrigerator and they'll last, a month. But if you set them out in my house, in my kitchen, at 3 or 4 days, they're already starting to swell and gas. So this is my issue. Hope you can help me out. Thanks.
Thanks.